Hello, my name is Wilczynski and I work at EnerMaps Research. In this video, I will be explaining the building heat load calculation module that is being developed for the EnerMaps project. This calculation module calculates the space heating demand profile for a user-configured building in a user-defined location, allowing researchers to gather insights on building-level heat demand for different locations in Europe. The calculation module utilizes two central data sources to compute a building's heat demand profile. The main dataset is the Building Characteristics database from the Tabula Episcope project, which includes building typology data for different regions in Europe. Second is the Copernicus Climate Database, specifically the hourly temperature and hourly surface solar radiation datasets. A subset of these data will be extracted based on the coordinates identified by the user and used in the calculation of space heating demand. By using country-level building data from the Tabula Episcope project, as well as spatially explicit hourly data from Copernicus, the building heat load calculation module utilizes a resistance capacitance model to simulate the space heating demand of the configured building for a specific location. Currently, the calculation module is still being developed, as is the front end and integration with the EnerMaps data management tool. However, I can demonstrate the current state of the calculation module. The interface will look similar to this, where the user must first select an eligible area on the map and then call the building heat load calculation module. They are then presented with a menu of options of the building that they have to define, including the building type, construction class, and area. The building type includes 4 options for the user: apartment block, multifamily house, single-family house, and terraced house. Additionally, the user has 8 different construction periods to choose, from which will also dictate the level of efficiency of the building. Finally, the user defines the floor area of the building, which dictates the amount of space that needs to be heated. After submitting their request to the calculation module and waiting for a brief calculation period, users are provided with a series of outputs. An outputted figure will show the hourly heating load profile for an entire year, starting from the first hour of January to the final hour of December. Additional KPIs will also be presented, including total annual heat demand values, monthly averages, and peak load values. However, the main value of the output is the user's ability to download a CSV containing the profile data so that they can further inspect and manipulate the data. For example, from this data, users can narrow in on a specific day and view the hourly heat demand profile for that day for their selected building and location. Or they can compare the space heating demands in different locations or different building configurations. And finally, they can use their generated data as an input in further models which require building level heat demand data. Thank you for your attention, and I look forward to sharing updates on the development of this calculation module in the future.